We are in this book here, Generalized Linear Models with Examples in R, Chapter 6, and, Chapter 3, and Question 3.6. Okay, so we are meant to show that the partial residual plot for a simple linear regression model is simply y plotted against z, against x. Okay. Now, in a way, this is just, this is almost tautological because the partial residual is the residuals with the linear component added back, at least of one of the variables. And here we only have one variable, and that's x. So we're just adding back the linear effect of, or the linear component of y per x. Okay. So the way to demonstrate this, or that I'm going to demonstrate it, is I'm going to make some data here. So here I have my x variable, and then my y variable, which is dependent on x. So let's see how I did that. So I'm assigning my mean value, which again is the linear component, some function of x. And here I have 1 for the intercept plus 2 times x. So the beta coefficient, the slope on x here is 2. So the mean here is the linear component of our model. And now, so I'm generating random values with the mean of this with a standard deviation of that. So now my residuals are going to come from that component right there. Okay. So now I'm running a linear model, and now I'm going to calculate the partial residuals. Well, how do I do that? In fact, maybe just to make this clear, I'll put this over here. Okay. So so normally, if I just wanted my residuals, I could use this command, and that would give me the residual. That would give me the actual data point minus the predicted data point for every value in my data set. Okay, and then to that, I am adding back my linear component. Okay, so what is my linear component? Well, it's my estimate of the first coefficient, which is the intercept, which I've set to be 1 here, but it'll be a little bit different because of sampling variation and how we generated the data, plus x and its slope, the second coefficient that was estimated, which I've set to be 2, and it'll be slightly different than 2 just because, again, of sampling variation. Okay, right? And so now, I have my linear component, which is reflected in how I generated y, as well as the residuals, which are coming from the standard deviation. So you can see that it's almost tautological. It's almost just a restatement of how I generated the data. Okay, so now I'm going to plot y versus x. I'm going to plot the actual data of y versus x here. Okay, and those are going to be just empty black circles. And then over top of that, I'm going to plot points of the partial residuals, and I'm going to have those being filled pink dots. Okay, and you're going to see that they just completely align here. All right, and so that's what it looks like. Now, there's one thing here that I don't think is actually correct, and I only did it so that I could get this particular plot just to demonstrate what the question is asking us to demonstrate, which is in this partial residual plot. I don't know if it's appropriate to include the intercept or not, right? So if I didn't have the intercept in my partial residuals, then all of the pink dots, they would be down by 1 or roughly 1, getting rid of the intercept. But anyway, I think we'll call it good there.